Okay, hi, this is Francois again. I think we're going to get started here. Thank you so much for everybody who's joining. I recognize a few names here. It's great to have you and join this webinar. So today is about simplifying API access control with OAuth. I'll be presenting. My name is Francois Lascelles. I'm the Director of Solutions Engineering at Layer 7 Technologies. And presenting with me is Steve Copeland, who's a Senior Analyst at 451 Research focused on enterprise security practice. I'm just going to maximize my screen here. So here's a few housekeeping items. We really want to hear from you. So if you have any questions about the material, the patterns that we're talking about, we want to hear from you. You can use the chat window to post these questions, and what we'll do is at the end of the presentation, we'll try to go through as many of these questions as possible. You can also stay connected. There's a Twitter hashtag there that's provided if you want to stay connected during this event. You can follow us on Twitter. There's a number of relevant Twitter handles there, and as well as our links for Facebook, LinkedIn, and our blogs. There's going to be another webinar as well on April 19 with Redmond, so stay tuned for that one. So before I pass it to Steve, this is what we're going to go through today. So Steve will talk about, introduce the API revolution, concepts like API management, SLA, and identity management logic. How does you integrate identity management with the specific API infrastructure, understanding OAuth security and identity management? And after that, I'll be talking about specifically API management infrastructure, how that's leveraged to do access control with OAuth, how that uses things like API keys, SSO, and identity attributes, how OAuth intersects with things like SAML and Example. And then at the end, I'll very briefly introduce the Layer 7 solution around this. So I'll pass it to Steve now.
Yeah, thanks everyone for joining us this morning. As Francois mentioned, I'm a Senior Analyst here at 451 Research, and our firm's enterprise security practice. By way of background, 451 Research has been around for almost 12 years now, focused on emerging technologies for enterprise IT. The scope of my research specifically is around identity and access management and increasingly data security. And in terms of broad trends, we look at how cloud computing and mobile security impact identity and access management. Over the course of the last year to 18 months or so, we've seen a new access management edge emerge, if you can call that, for open APIs that are published either inbound or outbound. And over time, we believe that this API revolution will fundamentally impact access management trends. So by way of introduction, my section of the webinar will discuss how we got there, the relevance of APIs from an enterprise IT perspective, and how to offset risk to take advantage of the API revolution through pragmatic access management initiatives. Francois will take a look at more practical questions of how to use OAuth in real-life cases. So just to manage expectations, expect to see more text in my section of the webinar and a lot more in the way of technical representations and patterns in Francois' sections. So with that, let's take a look at the agenda. First, I'll discuss how APIs gain prominence in the management of enterprise applications and why we see APIs becoming more critical in our applications are built, accessed, and secured. Then I'll discuss the overlap at a conceptual level with existing access management principles and how API management has resulted in the convergence of what were formerly two discrete markets. Then we'll talk about how identity management process can be extended to deal with a new set of use cases for managing access to APIs that present themselves as adoption moves up the maturity model. And then we'll highlight the role that OAuth now assumes in melding API management, federation, and access management in this new scenario. and I'll hand over to Francois to illustrate a few practical examples. So the notion of an API is hardly a new one. Open APIs are a relatively more recent development, but fundamentally their function hasn't undergone a radical change. They remain a systematic way of exposing internal set of resources, services, or a store of logic to a third party. What has changed is the architectural environment and the ability for developers to use standard ways of invoking an API and integrating a set of services effectively through concatenation without much in the way of expertise required. Also because of the consumerization of IT, the type of applications that APIs were designed to enable in the Web 2.0 world are now becoming the standard that users expect, whether for personal or professional applications, and especially in terms of mobile or tablets use, specifically the iPad, which you've seen, growing in at a pretty steep adoption rate, as well as Google Android devices. And from a technical perspective, REST is effectively an extension of HTTP. It's fundamentally altered how applications are composed and brought together. I'm sure many of you this webinar remember the debates about SOAP versus REST. This is practically ancient history now, since REST won out on ease of implementation, and this is critically where developer expertise was concentrated. But as we look at broader enterprise adoption, the arguments that characterize that debate are now being reflected in the new requirements for API management, access and security, where OAuth starts to feature as a critical building block. So we wouldn't be an analyst firm worth its salt if we didn't make bold predictions. And by bold, I suppose, I mean somewhere between pie in the sky and glaringly obvious. Still, we think it's not unrealistic to argue that an API-centric model is where the application world is heading, whether it's in the context of platform as a service, or SaaS environments like Salesforce, Google Apps, Workday or others, or hybrid model of SaaS and PaaS, as well as in the development of customer-facing enterprise applications. The reasons for this are already largely evident. It's a more cost-effective way of getting an application up and running, requires less in the way of developer expertise in coding, and allows for reuse of resources as well as straightforward integration of third parties. Certainly, we think it's hardly controversial to posit that the API revolution has gone mainstream. With this API model going mainstream, we as an analyst firm have seen what were two discrete markets and functionality focuses converge on a set of requirements that span the developer community, the application owner, the enterprise architect, and increasing the CISO. The market targeting the developer community, not surprisingly, developed earlier, and vendors focus on enabling scale and availability of the API with a relatively flat view of the security and access management requirements, and more specifically around management of API keys or identity management. They did, however, build infrastructure to allow organizations to quickly get an API initiative in place, enroll developers, and manage connectivity, all the while handling the infrastructure requirements. More recently, we've seen vendors with a heritage in SOA and web services migrating to this market, with Layer 7 and peers obviously a case in point. For these vendors, it's a logical progression from acting as a gateway between inbound sessions to an internal set of services and enforcing federated identity logic. Plus, these gateways can also serve as a bidirectional policy enforcement point using parameters like session flow, identity, and elements like JSON messages. Also, by virtue of that product architecture that serve as natural collection points for events and user activity or services activity, which can then be exposed in reports or logged and sent on system. Where these vendors still have ground to cover is in terms of functionality aimed at the developer community, including portals and other similar features. But in the background of this convergence is a broader trend towards the evolution of what we've elegantly referred to as a cloud access gateway. As a result of the trend toward hybridization created by the adoption of cloud computing and those pesky iPads we mentioned earlier, what we traditionally call the edge doesn't just go away, it moves, and it moves dynamically. This creates the need for a gateway that can manage at multiple and dynamic edges. Over time, this cloud edge device could also provide some ability to manage bidirectional flows between on-premise and off-premise infrastructure in order to enforce a consistent set of security and granular access policy across hybrid environments. This could be described as cloud access governance. From a functional perspective, then, this flow management will entail some ability to transpose internal logic onto external environments, such as an infrastructure service instance or a virtualized session running an external server. This functionality would enable cloud service providers, for example, to enforce rules or policies on traffic between the service consumer and the cloud while maintaining interoperability and session continuity. The cloud gateway would effectively act as a proxy between clouds, virtualized data centers, and internal resources to migrate policies with the workload. So the adoption of an API-driven services-based architecture reinforces this notion, especially when we think of creating a new edge between a set of applications and users who are not employees, but are customers, partners, or third-party developers. So what were once XML gateways go through the process of morphing into network devices that manage and secure enterprise APIs with identity management and authentication forming crucial elements of how API sessions are brokered. The strategy that we've seen built around consolidation of access management, federation, API management, and authentication at a cloud access gateway suggests to us that this model is becoming increasingly important from a broader governance and security perspective. Here, again, we want to call out OAuth as a critical building block in injecting a policy enforcement overlay onto API sessions. But even as these markets converge and we see this notion of a cloud access gateway being solidified, there are a few challenges specific to API management and API access management that present themselves. And that are incremental to the way that Web 2.0 APIs like Facebook or Google Maps have been managed in the past. As enterprises and service providers look to secure and scale the exposure of a set of RESTful APIs for mobile applications, for example, to developers and partners, they have to deal with a different class of users. As well as they have to be able to present a set of metrics to application owners and demonstrate conformance to service level agreements. For aspiring application store owners, which we've seen kind of emerge within the service provider world, there needs to be a bridge between federated identities coming in over the API and links with extensive investments in customer billing and subscriber management systems. On the supply side, the growing appetite for the cloud marketplace model is driven by ease of management using a standardized process and delivery mechanism. In addition, this app marketplace model presents a potentially lucrative service platform by aggregating traffic from both consumers and business customers. However, even as these two sectors converge, we see some significant structural differences emerge in enabling this type of business objective. So if we factor in the specifics of API management and the multiplying cloud edges, we end up with a situation approximated in this graphic, where the enterprise is both an application publisher and consumer, and security, governance, identity authentication, federation, and provisioning are managed through a centralized mechanism. Where OAuth fits into this picture is in terms of both inbound and outbound sessions. Every time a session crosses a domain and there's services interaction, there needs to be integration of logic like user profile, authentication status, and associated authorization logic into the session. OAuth, at its core, enables this connectivity, so session integration is dynamic. and enables the exchange of identity management logic at runtime. If we look at this diagram and ask ourselves where does Authority store for users reside for all these interactions, why OAuth functionality is important starts to become apparent. Enterprises simply don't want to have to manage a whole new set of identities, but certainly want to know who their customers are and partners are, and integrate that into the session management. Federation built on OAuth connectivity and token exchange, and then on top of that, exchange of session and policy logic in the form of SAML tokens, JSON messages, or even XACML, allows for more flexible and scalable execution model while still meeting security requirements. But there is a need for some entity that provides the integration and session management at the API edge. Another implication is that as API management use cases become more complex, identity management functionality becomes more important, not just for federation, authorization, and provisioning, but also for understanding the API in the business context. And identity can become a pivotal parameter in terms of infrastructure management if there is a need to provide a very granular defined set of service differentiation. And equally, there's a need for an edge device that allows for existing identity management logic and policies to be reused. You may want to rebuild an application and connect more effectively with partners through an API-driven strategy, but still use an existing model for mapping federated identities and processes for just-in-time provisioning based on account information, as well as aggregating data for reporting and compliance. Because a new class of APIs represents a change in how applications develop, manage, and employed, we think it's important to highlight that you do have to evaluate your needs in a specific context. Although we clearly believe there's a platform evolution underway here, there's certainly scope for coexistence of technologies and what might be understood as horses for courses. The more sophisticated the application, the more important reporting analytics might be. The API initiative is aimed at establishing new revenue streams by opening up an API to developers. Then perhaps the portal might be more of a consideration. So if the point of commonality between the two worlds of API management is OAuth, where do the strengths and weaknesses lie? As a frame of reference, we should note too that it's just as important to find what type of API we're referring to and what functionality is a priority in the context of the service. Again, we'd also point out that there may be ways to mix and match functionality as requirements demand. Here, Identity Federation provides a point of commonality, and again, OAuth serves as a tool for bridging these discrete functionality sets. Obviously, this creates more complexity in terms of management of multiple technologies, but since the market for enterprise and service provider API management is still early on in its development, we see this mix and match approach having some appeal. But as organizations expand the scope of API projects and this trend toward API-centric development engagement becomes more central to overall IT strategy, OAuth serves the means of injecting identity as a policy construct to address these range of questions that present themselves. Who are your users? Who are your customers? Who are developers? How do you onboard and enroll users and provision services? What type of SLAs can you associate with a particular user set or a specific user profile? We should be clear, though, that OAuth in of itself does not resolve these questions. It provides a way for sessions to be bridged and for integration of more logic at the API. At its most basic, an OAuth token can provide an assertion to the user as an authenticated user. Beyond that, there needs to be an integration of the store of identity management logic and a means to use that OAuth token as a starting point for policy enforcement decisions based on that identity management logic or as an initial parameter for reporting in the context of service level agreements or performance metrics. In terms of the business rules, that token can also be used to determine which API the session should be directed to, as well as session performance characteristics for the device that the user is accessing the application from. The appeal of OAuth is that it's a protocol that's designed to function across RESTful APIs at runtime and complement existing identity management protocols, notably SAML, as well as the web design fundamentals like JSON. So where the requirements are more sophisticated from a business perspective, we've seen organizations look to reuse in-house investments and convert existing logic to operate in this new environment. Existing functionality and logic does become a foundation to securing, scaling, and automating management of APIs, albeit in a new environment with OAuth and SAML now playing a central role as the integration glue and as a wrapper for authentication tokens. Reuse of existing identity management infrastructure, policy, and process includes authentication by software or hardware token, or by a self-generated session like a Facebook or Twitter login based on OpenID Connect principles. Federation and secure token services, so that external users can be mapped to internal resources, and some session management can be implemented. User stores, potentially a flat file that stores credentials, so that authorization can be performed on the fly by the application, or directories, potentially a directory in the cloud that allow for better utilization of third-party APIs, single sign-on both in the context of incoming API requests, whether it's by consumers, partners, or developers, or in the context of developer portals or app marketplace portals. Also, attribute brokering at the gateway, provisioning and self-service, sometimes based on what we've heard, the concept of bring your own attributes, where users are authenticated to an API, where third-party authenticates users to an API on their behalf, profile synchronization across multiple APIs, application connectors for SaaS offerings, as well as XACML processing and decision enforcement, and lastly, reporting and auditing based on identity profile. Again, to call out where OAuth fits in is providing that connectivity to the API, especially wrapping up authentication from a mobile device, at which point a broader set of access control management policies and rules kick in. So one of the open secrets of OAuth is that it isn't actually a security protocol. Certainly it can fulfill some security functions, but if it's not specifically implemented to provide authentication for non-repudiation purposes, an OAuth token can simply serve as it does for many API use cases as an API key that isn't set to expire, but which is unique to a developer. But I hope I've managed to outline why OAuth is an important building block in terms of access control for APIs, especially in terms of providing connectivity and foundation for integration of identity logic and access control rules at the API. Also, when considering the other side of the coin in the major topological transformation in enterprise IT, OAuth is pretty much the only game in town for providing a framework for authenticating sessions from mobile endpoints. With OAuth-based authentication in place, the mobile endpoints can start to participate in a token exchange. That can be enriched at the gateway with SAML assertions or associated JSON messages, and eventually XACML policy message or even simple cloud identity management or SCIM messages for dynamic provisioning requests across APIs. So to summarize, we first of all see the API-centric model becoming the de facto approach to building new applications. This trend compels organizations to understand how to manage third-party identities, manage access from a greater diversity of endpoints, and invest more heavily in federation and services provisioning. The end result is a combination of reuse of existing logic, extending identity and access management investments to new use cases, but also wrapping up access management processes in new technology. OAuth, despite its limitations, is both a starting point for dealing with these new cases and a foundation for a new technical framework for services-based architecture accessed by a broader range of users and a broader range of devices. And with that, I'll hand over the reins to Francois to walk you through the practical implications of access management for APIs. Thanks for your attention, and look forward to fielding your questions.
Thanks, Steve. I'll just switch over here. Switch over to these slides, and I will maximize my display. So as Steve was pointing out earlier, all the world's an API, and whether you are reaching out to a target audience through things like mobile applications or you're simply leveraging APIs to do integration in general, you're relying on an infrastructure to do this in an agile way. So the subset of your API management infrastructure that relates directly to access control, which is what we're talking about today. So first, you have a developer portal for the API consumers to discover APIs, register their use, and get an API key. And second, you've got a runtime enforcement which acts on behalf of your APIs, controls access in real time, checks token validity, enforce SLAs, and things like that. And third, you've got a token management aspect to your API management, which controls the life cycle of your access tokens. So if you look at how OAuth works, you can break it down in two parts. First, there's the OAuth handshake, during which a token is issued. And second, the consumer uses this token to consume the API. So sometimes the API is consumed on behalf of another party which is involved in the handshake. So the second part here is when the API is being consumed. And OAuth talks about protecting resources. It's very resource-oriented, and therefore OAuth is very relevant to RESTful type services or APIs. And although OAuth was originally created to address a specific three-party authorization case, in OAuth 2, OAuth 2 defines 4 different grant types, and grant types are types of handshakes. Some involve 3 parties, as I illustrate on my slide here, but some are simpler and can only involve 2 parties. And there's also extension grant types that can be used with OAuth 2, and a good example of that is the SAML bearer extension type, which I'll discuss later in this presentation. So just a little bit of OAuth terminology. There are a number of roles that are defined in OAuth. First, there's the OAuth client, which I label application on the slide. This is the consumer application of the API being protected. There's also the definition of the resource owner from an OAuth terminology, which I label subscriber here. And this is an identity that the application acts on behalf of when it consumes the API. This is not always present depending on which grant type you're using. And then you have the OAuth provider itself on the API side, and this consists of 2 components. There's the OAuth authorization server, which is doing the handling of the handshake, and there's the OAuth resource server, which is controlling access at runtime. So these last 2 components are part of your API management infrastructure for the APIs that you provide, and they act on behalf of your backend API instances. And so during an OAuth handshake, the OAuth authorization server component will have to authenticate a subscriber. And so these resource owners, these are the subscribers of your service for which the application consumes the API on behalf of. So for a lot of people that we work with, another term for this is just their identities, or just their users. These are your users. And for most API providers, these identities exist before and independently of any new API. If these users already exist, you probably already have a way to check their identity. You might already be managing those identities in an existing identity solutions and so on. But now you want to leverage these identities in the context of an API access control. So maybe you should replicate these identities in your API management solution. Of course, now, identity silos are a very bad thing. You want to continue to have a single point of administration for your existing identities. Your API management infrastructure will just have to integrate into your existing enterprise infrastructure ecosystem in such a way that the authentication of the subscribers during the OAuth handshake involves the existing AIM infrastructure. Do you need to change anything about your identity management in order to accommodate these OAuth handshakes? Probably not. You just need an OAuth authorization server that can interact with it so that can verify the identity during the handshake. In that case, in the case I illustrate here, the subscriber provides credentials during the OAuth handshake to the OAuth authorization server. In some cases, a challenge is sent to the subscriber so that credentials can be presented. The OAuth authorization server then consults the existing identity provider to verify the identity of the subscriber and remembers that identity as being associated with the access token that comes out of that handshake, if you want. So, as I mentioned in my previous slide, only in certain grant types is the resource owner or the subscriber authenticated. Remember that in OAuth, there are potentially two identities that are authenticated. One is the resource owner, and the other is the client. And so here I illustrate which grant types authenticate which identities for reference. For some APIs, it makes sense to support multiple grant types. So for example, you might have an API that is accessed by both external requesters using the authorization code grant type and internally by an enterprise integration application, which would act not on behalf of a subscriber, but would act from the perspective of the API provider. So for those types of requesters, you could rely, for example, on the client creds grant type. So it's also important to be able to authenticate OAuth clients, not just the subscriber. So we've seen how to incorporate an existing identity infrastructure into an OAuth handshake to authenticate resource owners, the subscribers. But now, how do you deal with client application identities? So OAuth specifies two types of clients. There's the confidential client type and the public client type. So if a client application can maintain its credentials secret, it is considered a confidential client. Otherwise, it's a public client. And in the case of a public client, you can still issue an API key, although any shared secret associated with it would be meaningless. It becomes a way to identify a client in a non-authoritative way, for example. But for confidential client, you can assign a shared secret through a developer portal in order to authenticate the client during an OAuth handshake. So although the concept of subscriber as an identity usually predates an API, the identity of the application that consumes this API on behalf of the subscriber does not necessarily predate the API itself. Therefore, it's more common for the management of the application identities as opposed to the subscriber identities to be integrated into the API management infrastructure. The reason why this is acceptable is that these identities are created for the sole purpose of the API consumption and do not exist outside of that. But if that's not the case, and you already manage identities that are attached to these applications, then the reuse pattern applies, just like we've seen for subscribers. So normally when you talk about verifying the identity of a requesting application, you're talking about using API keys. And as an API publisher, you provide these API keys through a developer portal. The developer portal is there to facilitate the process of onboarding these developers and issue API keys to these developers. And a developer portal persists these API keys in such a way that they can be looked up and referred to during the OAuth handshake by the OAuth authorization server. The user experience associated with an OAuth handshake is very important. As a user, it can be very annoying having to provide credentials all the time. It can also be a source of suspicion when you're being prompted for credentials. And because of this, it's important to integrate the look and feel of the OAuth authorization server with the rest of the subscriber experience. Let's say that I'm the subscriber or the resource owner in OAuth terminology, and an application redirects me to the OAuth authorization server of the service provider in order for me to grant access. I probably don't need to be aware that this is an OAuth authorization server at all. I probably don't know anything about OAuth. The only thing that's important here is that I want to express this consent for the application to consume this API on my behalf. And if I'm interacting with this provider using, for example, a web application, I'm used to a look and feel that needs to be replicated at this stage of the handshake. If I already have a session with the service provider web application, that session needs to be honored. In other words, I should not be prompted for credentials unless I don't happen to have a session. Obviously, the OAuth authorization server needs to verify the identity of the subscriber. This is important. So the OAuth authorization server should be able somehow to consume this existing session. The way that it is done usually is through an SSO cookie that is automatically presented by the subscriber user agent. The OAuth authorization server needs to be able to validate this cookie, get information about it, the identity behind it, and this is done by having the OAuth authorization server interacting with an SSO policy server, for example. And know that when the handshake is complete and an access token is created, the original SSO token used to authenticate the subscriber should be recorded as part of the OAuth session for later reference. Accessing an API using an OAuth access token sounds pretty simple, right? You present a valid access token and you're allowed to consume the API, or are you? The thing is that access control needs to be more granular. An access token should only authorize access to resources that are acceptable based on the subscriber identity associated with the token. So access to resources might be based, for example, on a group membership, a contract, it could be an API plan, or any other arbitrary attribute that are associated with an identity. And also, OAuth has the concept of scope, and a specific scope can be requested by the client at handshake time. And of course, the OAuth provider doesn't have to agree with the requested scope. The scope can be limited by the provider side. But in that process, there needs to be some sort of authorization check. And that is a good example of why an OAuth authorization server needs to be able to integrate with the various sources of information relating to the identities, things like directories and databases as part of the enterprise IT infrastructure. Okay, now that you have access to these identity attributes, as part of the API access control infrastructure, how do you actually use it? In the previous slide, I was showing you a pattern where the OAuth authorization server checks these attributes for authorization checks during the handshake itself. This is certainly important, and you want to attach this information to the OAuth context. However, the authorization checks that you do at the beginning of the token lifecycle are not always enough. So first of all, OAuth access tokens, they are ephemeral, They have a short lifespan, but they are meant to be refreshed so that you don't have to involve a user to re-handshake all the time, depending on which handshake type you're relying on. So if that's the case, the authorization check done during the initial handshake might be hours and days old. So if you recheck the authorization at each refresh, you end up with authorization decisions that are more, more likely seconds and minutes old as opposed to days and hours long. So in some cases, this is good enough. This is the right balance. And if you want real-time checks, you can also do authorization checks at runtime. In this case, the authorization check is not performed by the OAuth authorization server like we were seeing in the previous slide, but instead by the OAuth resource server, and this is what I illustrate below. Another reason to do runtime authorization checks is if you need to check additional attributes that you did not foresee requiring later when you did the original handshake. So that would be another reason why you need to integrate with that infrastructure at that level. So how do you leverage SAML with your API access control? Now remember that OAuth has 4 different core grant types, but also allows for extension grant types. And one such grant type is the SAML bearer one. So the idea with that is that you've got an attachment specification that describes how an OAuth client, the API client, would exchange a SAML assertion with an OAuth authorization server in exchange for an OAuth access token. The specification does not get into any detail as to how that client application gets the SAML assertion in the first place, but this is where you would use another specification, for example, SAML web browser SSO, or it could be a portal that got a SAML assertion from another means. It could be SAML token profile or anything like that. But the idea is that the OAuth authorization server needs to be able to consume this incoming SAML assertion, and it needs to create an OAuth access token that relates to the properties of the SAML assertion. For the client application, having an OAuth access token is much lighter weight, and it's much easier to use for REST interaction at runtime. An average SAML assertion could be easily 4 kilobytes. XML is very verbose. SAML assertions have XML digital signatures in them, so that's much too heavy to integrate as part of a REST client. So in your OAuth authorization server, in order to implement this, you need to be able to leverage trust of existing SAML issuers that you partner with. So you would have to verify the SAML assertion during the handshake, verify that it's signed by a SAML issuing authority that you trust. And you would also leverage information about the SAML assertion to inject information in the scope of the OAuth session. So you can use, for example, SAML attribute statements, or you can leverage the issuer of the SAML assertion to specify a scope that is relevant. And unless the SAML assertion has a very long lifespan, it makes sense to tie the expiration of that OAuth access token with the expiration of the SAML assertion itself. You might want to make this shorter, obviously, if you're in a situation where your policy for OAuth session lifetime is shorter than the SAML assertion that comes in. So how does OAuth and XACML intersect? And can you involve an existing XACML infrastructure in order to control access to your APIs? So what I illustrate here is an OAuth resource server, which at runtime would also be acting as a policy enforcement point. So imagine an OAuth resource server that gets a request for a specific resource and would construct an XACML request using information associated with the access token that comes in at runtime. And this is where the token management part of your API management it starts to get really important. You need to be able to retrieve information, attributes that are associated with that access token, and you're using that to construct an exact mode request that you send to a policy decision point, and that centralized policy decision point would verify its own exact-based policies and return a response to tell the OAuth resource server whether or not this API call should be authorized. So yes, there is an intersection between XACTML and OAuth, and this is how it would look like. So I've gradually introduced the concept of token management and how it's being used during handshakes and during API consumption. But token management in itself is an asset that can be leveraged in other ways. Being able to monitor how often specific tokens are being used can be useful to the different parties involved. As an application developer, it allows you to check that your application is behaving as intended. As a subscriber, it shows you that an application is acting on your behalf. And as a provider, this is very important for reporting purposes, also to be able to monitor and look for unusual behaviors and things like that. And even if you don't provide a lot of visibility on tokens outside of the provider realm, the ability to be able to revoke those tokens is extremely important to all the parties. So imagine that I'm a subscriber and I grant authorization for an application to consume an API on my behalf, and as part of that authorization grant, I would get an email confirmation by the provider. The provider would send me an email that would confirm that I've authorized an application to consume this API, and it would be nice if I had a link referred to in that email that would allow me to easily revoke this access. I might also want, as part of the subscriber portal, I would like to be able to see all the applications that I've granted access to, and being able to revoke some of them if I feel that something might have been compromised. And the same thing from the application provider or the developer side of things. You know, for example, what if an application is compromised and the administrator of that application is aware of that? They want to be able to go into this developer portal for this API and being able to view all of the OAuth sessions that are owned by this application that is not compromised and revoke all of this, so that it makes sense to expose that information through the developer portal to the application providers themselves. So the token management has to provide this information to potentially a lot of sources. This type of integration is best served by itself using APIs, open APIs, of course. So Layer 7 provides a rich API management infrastructure. In terms of API access control, we have our own developer portal. This is a portal that is very customizable, has a full CMS. It allows developers to discover APIs, test API calls. We have something called the API Explorer as part of it. It allows you to register applications and onboard, get API keys and things like that. And then we have the API proxy, which is the runtime gateway that takes care of controlling access, doing all the routing, the mediation. It also does transformation and things like that. And then obviously the OAuth toolkit is something that you load onto those gateways to implement the handshake patterns that I was describing in this presentation. The OAuth toolkit implements all the versions of OAuth, all the grant types. It provides the token management API to do things like revocation and integrate that into your environment. All these components are integrated using APIs. They can all be integrated to work with existing systems in a very flexible way. So this is my last slide. If you have any questions about the Layer 7 solution, by all means, get in touch with us. There's some contact information here. And I think we're also going to start taking questions if there are any here. Okay, so I see some questions coming in the chat panel here. Somebody's asking, in a B2B scenario, who is the OAuth authorization server? That's a good question. I mean, you know, APIs are being used for integration in general, and even B2B is looking more RESTful every day now. So it is also relevant in B2B. So if you imagine an enterprise that supports a B2B with a partner, if the API exposes an API, if the enterprise exposes an API that facilitates that B2B pattern, then they are the API provider. They should provide an OAuth authorization server as part of this. That should be part of their API management infrastructure because they expose an API that their partners are potentially consuming. Steve, I'm not sure if you have anything to add on this one.
Yeah, I think it's interesting because you start to get into the realm of defining what's an identity, right? And to some extent, you know, when you are talking about a B2B scenario, you may be talking about one API speaking to another API. So the question is you know, who's the relying party and who's the you know, who's the identity provider? And I think that needs to be it's a question that's not entirely a technology question that needs to be resolved. You know, outside of the technical integration, it's really a kind of business question more than anything else.
Right. Yeah. So somebody else is asking, you know, what's the difference between a service and API? That's also something that you know, a lot of people sometimes are struggling with. You know, when are you talking about services? When are you talking about APIs? There's definitely a lot of similarities. You know, I would say that you know, when you're talking about APIs, you tend to think more about a RESTful pattern. What do you think, Steve?
Yeah, I think there's also the distinction between, well, you know, a service is discrete, and API is a way of managing integration between a discrete set of services. And the whole idea behind RESTful APIs is that from the kind of, you know, the runtime or the session perspective, essentially that integration is transparent. So there's you know, you can see how the things like you know, the concepts bleed into each other, but an API is really, you know, that kind of new edge, right? Between sets of services. So the sets of services you can, you know, maybe you kind of perceive to be a kind of, you know, whole, but the API underpins that services integration.
Yeah, absolutely. Yeah. Oh, somebody says they lost audio. I hope we're still on. There's another very good question that I see here. How does OAuth compare to WS Federation and SAML? I get this all the time. When people think of OAuth, they tend to correlate that to Federation because sometimes these different identities involved in a handshake. But really, you know, I would say OAuth is not about Federation the same way that SAML is about Federation, because if you think of how OAuth is used, you know, really the protocol defines how to go about the handshake, get a session involved, and then being authenticated as part of that session. And the API provider in that case, you know, issues the token and consumes the token, whereas with SAML and WS Federation, you have more of a situation where the service being consumed does not directly understand the consumer identity and therefore relies on another party to make statements about that identity. And so I think that it does relate. It does intersect, like we've seen how the two intersects in my slide about XACML and SAML, but they're not clear parallels, if you want.
Right. I think from a theoretical perspective, I think OAuth was, the scope of OAuth was very much around specifically what you're referring to is how do you establish, you know, connectivity or establish a session on a dynamic basis. WS Federation and SAML relate more to what kind of logic can you assert as a relying party to an identity provider that allows you to authorize a particular session. So the reality is that we have seen some kind of overlap because a lot of people look at OAuth as a way of federating identities. But if you kind of draw back and look at the scope, there's a lot of it's more complementary than overlapping.
Yeah, agreed. I see somebody asking if are you as sexy as you sound? That must be a question for you, Steve. Yeah,
right.
I don't.
Well, I don't know which is more appealing, the French Canadian or the South African accent.
That's right. Yeah. And the last question I see is what does O stands in for OAuth? I believe I just think of OAuth as OAuth now, and not as an acronym or anything like that. But I think originally it was meant to stand for Open Authentication.
Yeah, that's my recollection as well.
Yeah. Well, I think we went through the questions here, but definitely get in touch with us if anything else comes up. If you want to find out more, the recording of this webinar is going to be on our website. The slides are going to be on SlideShare. We have an event. Look at Layer 7 events. There's a lot of things going on these days. We have live sessions on Facebook that are happening next week, for example. So thank you so much for everybody who joined. And if you have any questions, please reach out to us.